I guess before we even start this, once again, let's slide left and let me show you the concept. All right? To add or subtract terms, let me ask you 3 questions as a preface. 2x plus 5x, 3a squared plus 7a squared, and 4x cubed plus 2x squared plus 3x cubed. 3 different questions. Give me answers to any one of the 3. Anybody? Luke. Number 1. 7x. Why does 2x plus 5x equal 7x? I'm going to make you support all your answers. Support your answer.
2 plus 5 is 7, and x plus x is x squared, so it should be...
Should it be 7x or should it be 7x squared?
When you multiply, you add the squares. When you add...
Okay, in one hand I have 2 pens. In the other hand I have what? Now I have what? 3 pens. Did the pens change? In one hand I have 2 x's. In the other hand I have 5 x's. I put them all in one hand and I have what? 7 x's. Do the x's change? So with addition, the x's don't change. All right? Second one, someone different. Second column. Someone in Zach and Noah's column. You're not in that column. Who's in the middle column? Answer me. Kyle, go ahead.
For number 2 would
Yeah.
be 10a squared.
10a squared. Once again, do the a's change? No. All right. Third column, you got this one. Jalon, Luke, James, and Ryan.
7x cubed plus 2x squared.
Why didn't you combine the 2x squared there?
Because they're different numbers.
Okay, they're different exponents. All right. Good job. So we can conclude from this that you can combine things that have the same variables with the same exponents. All right? That's the conclusion. Now, look at the original page that we had. This is extremely similar to what I just set you up with. When you see the square root of 3 and this square root of 3, imagine this is 6x plus 7x. What would that be if it was x's there? 13x, right? Or in this case, 13 square root of 3. What didn't change? The number of square root of 3's, okay? We have 6 square root of 3's, we have 7 square root of 3's, we add them together, we get 13 square root of 3's. All right, next one. 3 square roots of 7 minus 17 square roots of 7. Do we have the same square roots?
Yes.
So can we combine them? Yes. So negative 14 square root of 7's. So let's look at our comment at the top. To add or subtract radicals, the radicand. I need to remember some terminology. What is the radicand? All right, so put a little note here. The number inside the radical sign. James, are you familiar with that term, radicand? Okay, all right. Moving down. I put on C because it has a specific concept or idea. What do you think is the concept on C I'm trying to help you understand?
There's a 1 in front.
There's a 1 in front. So stick a 1 there. Physically, actually put a 1 there. And everybody write down what your answer is. Don't say it. Write down what your answer is. All right, Abby, what'd you put down? 3 square root of 5. Excellent. All right, D. All right, same thing. Write down what your answer is. You get 5 seconds to do this one. 5, 4, 3, 2, 1. Pencils down. Pencils down. All right, who wants to give us an idea? Who hasn't done one yet? Who hasn't given us an answer yet? willing to take a chance? Mr. Acosta. Yes, go ahead. You put the same thing. Isn't that kind of a cop-out? Not in this case. Why not? You're right. Exactly right. Sometimes it's hard not to change things, isn't it? Why can't we combine these, John? Yeah, they have different radicans. We just read at the top you can only combine them if they have the same radicand, and obviously these don't. What was I trying to sucker punch you to do here? Make it 2 or make it 3 or something, subtract it, but you can't. Curious, how many got it right? Nice. Good job. I was expecting very few. Good job. So the answer is exactly that. So what have we learned? You can only combine them if the radicand is the same. That was my point of giving us that example. Moving down. On E, is the radicand the same? How many square roots of 6 do we have here at the front? 1. Tara, help me here. 1 square root of 6 minus 4 square roots of 6. You got it. -3 square root of 6. All right, last one's on your own. Go ahead and write down what you think the answer is. It does have a simplified answer on this one. No trick question. Justin's got it. Justin, nice and loud. What do you got?
-8 square root of 2.
-8 square root of 2. All right, before we flip, questions so far. When can you combine radicals?
When the radicands are the same.
Now, what do you think, before we flip, what do you think is on the back page?
They're different.
Different what? Radicands. All right, now before we even get there, slide back to page 42. Okay? Slide back to page 42. I know, we're on 43.
No, we're on 30.
Well, yeah, that would be a problem for me. Slide back to page 30. Is that the blank page we were on?
No, that's the chapter review.
Okay. Then we'll go to the bottom of the page here. What is the square root of 75? Do a little review here. What did we talk about? How do you break that down?
Into the greatest square root.
Okay. Does that go to 25 and 3? And the 25 is 5 and 5. And you remember what we did here? We circled our pair. And what does a pair do? Comes out as that number. Yes, but that's the whole premise behind it. If on the back page, when we flip, we get numbers that are not like radicands, does it make sense that you might have to simplify them first and then combine them? All right, so now let's flip. What do you know? Look at example 2A. So our instructions say to add or subtract, the radicand must be the same. Sometimes you have to simplify first before combining. Is the radicand the same on the A? All right, so let's break this down. You're going to be very careful to write everything on each line. Someone break down 20 for me.
I got it.
Go ahead.
So it goes square root of 4 and square root of 5.
Okay, then I need to write the rest of the line. Okay, and how does 4 break down?
Then you go to square root of 2, square root of 2, square root of 5.
And rewrite the rest of the whole line. All right, have we broken it down completely? Circle your pair, guys. Now we need to remember a little bit here. That pair of 2's comes out as what? A single 2. So I've got, and I'm going to try to write every step here just so we don't get confused. Can I combine this 3 and 2? Does it make 5 or 6? It makes 6. Now, do I have the same radicand?
Yes.
So now can I combine them?
Yes.
All right, James and Ryan, what do you think? 6 square root of 5 plus 2 square roots of 5. I do. Do you agree, James? Okay. 8 square roots of 5. Bingo. When are you allowed to combine radicals again?
one there the same.
What's the same?
Radicand.
The radicand. All right, here we go. Yes, sir.
On our previous lesson, we're going to allow, if there's numbers outside the radicands, we can combine those and have the
If we are multiplying. But here, what are we doing between all of these? Adding and subtracting. No multiplying today. All right, here we go. Root 3. Someone break down that 75 for me. Brian, go ahead.
3 and 25.
3 and 25. Make sure you put them both in radical signs. Now I'm going to break down that 25 into 5 and 5. Justin and Haley, talk to me here. Okay. So that becomes, whoops, I got it right here, 5 root 3. Justin, can you finish it for her?
6 root 3.
6 root 3. Is this making sense? Break them down, then combine them. Why can you not combine these two? Not the same radicand. All right, moving down. What's different about C?
It's the subtraction.
Subtraction.
And they're both.
And they're both different. All right, let's break down the 8. Someone break down the 8 for me. Go, Luke.
You go down to 4, square root of 4, square root of 2.
Okay, we'll come back to that. Someone else. Sam, break down the 32 for me.
4 and 8.
4 and 8. Okay. Mr. Alba, break down the root 4, root 2 for me. Okay, 3 2s. All right. Mr. Sesnoff, break down the 4 and the 8 for me.
4 and 2 root 2.
For the 8,
4 and 2.
2 and 2. All right, circle all your pairs, guys. Moving over, Mr. Donsel. What's the first part become?
12 times 2 and square root of 2.
Good. Going back, keep going.
Minus 6 times 2
Good.
times 2.
Good.
The square root of
Good. Hannah and John, take it from there. Well, talk to me how you get to 0. It might be the answer, I have no idea.
So you go 24, root 2, then you multiply those out.
6 times 2 times 2. 24 root 2. Is 0 an okay answer? How often do you think you're going to get 0?
Not very often.
Not very often. But it just so happens when we simplify everything, it does break down and we get 0. Yes, sir.
I was wondering, on number D, could you combine the 2 3s or no?
These 2 3s? We did. Root 3 plus 5 root 3 is 6 root 3.
Oh, but no, do they have a 1 in front? So it'd be like 2.
What's 1 root 3 plus 5 root 3?
No, the one above.
Here?
Yeah.
No, because these root 3 is connected to the 5s.
Oh, okay.
You got
So
to
what is-
simplify first, then combine. You don't change what's inside the radical sign. All right, our last one. Here we go. Start me off. Jalan and Luke. Break down the 27, please. 9 and 3. Luke, your turn. Break down the 48. Good morning. When in doubt, take out a 2. Six and 8, okay. Going back from there, Luke, your turn.
3 square root of 3 and plus square root of 6.
Break down the 6.
2 and 3
Break down the 8.
and 4 2.
So here I got a pair, that makes 3 root 3. I got to finish breaking this down. Lots of 2s. Circle my pairs. What's the back half going to be? Help me here.
Wait, are you allowed to do that? Go
Sure.
ahead.
Just because they're not written next to each other, that's okay. This 2 goes with that 2. So how many pairs do I have back here?
2.
I have 2 pairs. So 2 times 2 is 4. So what's my answer? How many root 3's? 7 root 3's. Go ahead, Jelon. This one?
Yeah.
Well, the 8 is 4 and 2. And 4 is 2 and 2. So I have 2, 2, and 2. So this is the 8, and that's the 6. So the back half numbers, this is my 8 right there, and that's my 6. And there we go, 7 root 3. So to combine them, they have to be the same radicand. If they're not the same radicand on the front page, like our trick question, do you combine them? Just leave them. Don't combine them. Do you think most of them are set up today, though, that they will combine?
Wait, can you break that one down?
No. Well, you could break the 6 down to 2 and 3,
Yeah.
but is there any pair?
No.
So if there's no pair, you take it right back to where you started.
Okay.
Okay? All right, looking down here at the bottom. 12 problems, that's it. This shouldn't take long.